Hello, and welcome to this video. So, in this video, we will study 10 more problems of polynomials and quadratic equations. In the last video, we had covered till problem number 100. So, without further ado, let's get started. And as always, I will say that when I'm reading the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So question 101 says that if alpha cubed is equal to 1 and alpha is not equal to 1, find the quadratic equation whose roots are alpha plus alpha cubed plus alpha to the power 4 plus alpha to the power minus 4 plus alpha to the power minus 3 and alpha to the power minus 1, and alpha square plus alpha to the power 5 plus alpha 6 plus alpha to the power minus 6 plus alpha to the power minus 5 and alpha to the power minus 2. So sum of the roots is given as, I think there is some problem in question. Let me see. We have to find the quadratic equation whose roots are there. So we write the sum of roots, okay, as alpha plus alpha cube and so on. We write the sum, and then what happens is we remove the negative powers. That is, we multiply with alpha to the power 6. Okay. So why we multiply with alpha to the power 6 is because this is our highest power. Okay. So the equation becomes alpha plus alpha square plus alpha cube and so on up to alpha to the power 12. And sum of this would be 1 minus alpha to the power 13 by alpha to 1 minus alpha minus 1. Okay. Now this sum basically becomes minus 1 because alpha to the power 13 is 1. Let me look at the question carefully. Okay. So we have power of alpha to the power minus 6, and then we have powers up to alpha to the power 4. Alpha cube. So this contains 1, 3, 4, and this contains 2, 5, 6. Overall 12 terms, and if you multiply with alpha power 6, it will become alpha power 12. So, okay, fine, and this is good. So sum of these would be minus 1. We added 1 and we subtracted 1 here. Okay. Now, if we multiply these two roots, we will get 3 into alpha plus alpha square to alpha to the power 12. And then we have that as minus 3 because this sum we have evaluated as minus 1. So now we have two roots, minus 1 and minus 3. So the quadratic equation would be x square plus x minus 3 because sum of roots is minus 1. So this is minus b by a in the quadratic equation, x square plus bx plus c. So b by a is minus 1 here, and product is minus 3. So you know the equation whose roots alpha beta are x square minus alpha plus beta into x plus alpha beta. So our equation is x square plus x minus 3 equal to 0. Now we go to question number 2. Determine all pairs of positive integers m and n such that 1 plus x to the power n plus x to the power 2n up to x to the power mn is divisible by 1 plus x square and so on up to x to the power n. So from geometric progression, we have the sum of first expression as x to the power m plus 1 into n minus 1 by x to the power n minus 1. And sum of second expression as x to the power m plus 1 minus 1 by x minus 1. So we divide both of these, and the result is x to the power m plus 1 into n minus 1 into x minus 1 divided by x to the power n minus 1 into x to the power n plus 1 minus 1. Okay. So now we choose k and l as relatively prime. Then x to the power k minus 1, x to the power l minus 1 have a common factor x x minus 1. Now from De Moivre's theorem, we have x bar k minus 1 is equal to 0 as cos 2n pi plus I sin 2n pi by k, for n is equal to 0 to k minus 1. And those of L would be with L in denominator. With n is equal to 0, 1, 2, this should be L minus 1. Okay. So if L and K are co-prime integers, then other than 0, these roots will be different. Okay. Now sum of all the, since all the factors of x to the power m plus 1 into n minus 1 are distinct, x to the power m minus 1 and x to the power n minus 1 cannot have any common factors other than x minus 1. Thus m plus 1 and n must be relatively prime. Again, we see that x to the power m plus 1 into n minus 1 is equal to x to the power n to the power m plus 1 minus 1. So x to the power this we rewrite again x to the power m plus 1 to the power n minus 1. So x to the power m plus 1 into n minus 1 is divisible by both the factors in denominator. Thus it is sufficient for our result for m plus 1 and n to be relatively prime. So if they are relatively prime, then we have all the positive integer pairs of m and n. Question 103. So that a minus b whole square plus a minus c whole square is equal to b minus c whole square is not solvable, when a, b, c are all distinct. So we write the equation and square the values and we solve, we get the expression or equation a minus b into a minus c is equal to 0, which simply implies a is equal to b or a is equal to c, and therefore a, b, c cannot be distinct. But it is given that a, b, c are distinct, so we have a contradiction and hence we have no solution. Question 104 says that if px is a polynomial of degree m such that px is equal to 2 to the power x, for x is equal to 1 to 3 up to n plus 1, find x plus 2. Okay. So we write 2 to the power m as 1 plus 1 to the power m, which is equal to c0m plus mc0 plus mc1 plus mc2 up to mcm, for n is equal to 1 to up to n plus 1. This should be, yeah, up to n plus 1. Now we consider the polynomial. We have this as 2 into cx minus 1 0, c of x minus 1 1, and so on up to n. So if we see this function has degree n. So f of x is equal to 2 into 2 to the power x minus 1, where x is 1 to n plus 1. So we see that f of x plus 2 is 2 into cx plus 1 by x plus 1 cx plus 1 0, and so on. That's the binomial quotient, which is equal to 2 to the power 2 into 2 to the power x plus 1 minus 1, which is equal to 2 to the power x plus 2 minus 2. Right. Question 105 says that if a, b, c, d are all real, and a square plus b square plus c square plus d square is equal to ab plus bc plus cd plus da, then show that a is equal to d is equal to c is equal to d. So we can write the given equation as we multiply the left hand side and right hand side both with 2, bring the right hand side to left hand side, and then we have a minus b whole square plus b minus c whole square plus c minus b whole square plus c minus a whole square is equal to 0. Now all these are squares of real quantities. So we will have a minus b is equal to 0, b minus a is equal to 0, c minus b is equal to 0, and d minus a is equal to 0, which implies that all four are equal. Question 106 says that show that for x, y, z belonging to real number set, x square plus y square plus 2x square minus 8x, it should be probably y square. No, 8x square. Okay. All right, this is x square, this is y square. Then this should be z square, I believe. Yep, it is z square. This is not x, this is z. So 2x square plus y square plus 2z square minus 8x plus 2y minus 2xy plus 2x minus 16 z is equal to 35. There is a sign missing here, this should be plus. Okay, this should be plus and this should be z square. Okay. Plus 35 is equal to 0. So we write the equation, we bring in terms of x minus y whole square and x plus z whole square. Then this further gets solved and we arrive at x minus y minus 1 whole square into, plus x plus z minus 3 whole square plus z minus 5 whole square. Once we have these three equations, because x minus y minus 1 would be 0, x plus z minus 3 would be 0, and z will be equal to 5. So we solve this and we find z is equal to 5, x is equal to minus 2, and y is equal to minus 3. Question 107 says that find all real numbers that is find x to the power 8 plus y to the power 8 is equal to 8xy minus 6. Okay. So we have given that x to the power 8 plus y to the power 8 plus 6 is equal to 8xy. Yeah. So x and y must be of the same sign, otherwise left hand side would be greater than 0 and right hand side less than 0. Because x to the power 8 is an even number, so this would be positive, this would be positive, and 6 is positive. So left hand side is guaranteed to be greater than 0, while right hand side will depend on the signs of x and y, so they must have same sign. So if xy is the solution, then minus x minus y is also a solution. So without loss of continuity, we assume that x, y both are greater than 0. So we write left hand side as we split 6 into 6 ones, and so by n inequality we have x to the power 8 plus y to the power 8 plus 6 greater than 8 into 8th root of x to the power 8 plus y to the power 8, which is equal to 8 mod of xy. Okay? So by this hypothesis, our equality holds. From the hypothesis, we have our equality holds. So all the 8 terms are equal. Okay. Now, once we have this, you can say that x power 8 is equal to y to the power 8 is equal to 1, and therefore xy 1 1 or minus 1 minus 1. Okay. Now, by observation, you can see that the general solution of this is x to the power 2n plus y to the power 2n is equal to 2n xy plus 2n minus 2, where n is equal to 1, 2, and so on. You'll have the same solution set. Question 108 says, solve the system of equations for real x and y. The first equation is 5x into 1 plus 1 by x square plus y square equal to 12. And the second equation is 5y into 1 minus 1 by x square plus y square equal to 4. So we are given this equation, and what we do is we square it. So we get 25x square equal to 144 by 1 plus 1 by x square plus y square whole square. And the second equation is 25y square equal to 16 by 1 minus 1 by x square plus y square whole square. Now we add both of these, we get 25x square plus y square is equal to this much. Now we put 1 by x square plus y square equal to t. So x square plus y square is equal to 1 by t. So you have to solve a bit. This will be 1 plus t square, 1 minus t square, and then I made a mistake here. We don't have to solve reciprocal of this is 1 by t. So left hand side becomes 25 by t is equal to 144 by 1 plus t whole square plus 15 by 1 minus t square. Now we solve this and we arrive at this equation 32 into 5 into t plus 1 by t minus 8 plus 25. This should be 5 into 10 minus 8. It would be 10. 5t minus t square. Okay, this is correct. This should be square, I believe, because no, this is not square. This is t plus 1 by t. This is correct, and this is fine. So we arrive at the equation 32 into 5 into t plus 1 by t minus 8. Okay, we divide this entire thing by t. and we divide this by t square, we get 25 into t plus 1 by t whole square minus 4. Okay? There shouldn't be minus 4. Why there is minus 4? If we divide this by t square, okay. So there might be mistake. So I'll assume that this equation is correct, and I don't have pen and paper with me to solve this equation. Okay. So, divided both sides by t square. It's not one side is divided. We divide both sides by t square. Then we have this. All right, we find that. Now we put t plus 1 by t is equal to alpha, right? Once we put t plus 1 by t is equal to alpha, we have the equation 25 alpha square minus 160 alpha plus 156 is equal to 0, which gives us alpha, which gives us t plus 1 by t. We get two equations, and the equation of the discriminant of one of those equations is less than 0. So we have no real roots. For the other equation, we have two roots, 5 and 1 by 5. So now we have two roots. So we get x square plus y square is equal to 5 and 1 by 5. So we solve for x and y, and we arrive at the solution x is equal to 2 by 5 and minus 1 by 5. Question 109 says that solve the system x plus y into x plus y plus z is equal to 18, y plus z into x plus y plus z is equal to 30, and z plus x into x plus y plus z is equal to 2L in terms of L, where x, y, z and L become two positive real numbers. So we add all these equations, and we get x 2 into x plus y plus z the whole square. Okay, is equal to 48 plus 2L. All right. So how did you get to this? X square is, if we add y plus z, z plus x and x plus y, you get 2 in 2x plus 2y plus 2z. So left hand side becomes 2 into x plus y plus z whole square, which is equal to this x plus y plus z is equal to square root of 24 plus L. Now we divide all the equations by x plus y plus z, you get x plus y is equal to 18 by square root of 24L, y plus z is equal to 30 by square root of 24 plus L, and z plus x is equal to 2L by square root of 24 plus L. Now we have three equations, three unknown. We solve them, we get this solution. Next we can resolve. Now we come to the last problem, that is question number 110, which says solve x plus y minus z is equal to 4, x square minus y square plus z is equal to minus 4, and x, y, z is equal to 4, where x, y, z belong to the set of real numbers. Okay, this number is. So from first equation, we have x minus z is equal to 4 minus y. That is this equation. X minus z is equal to 4 minus y. So we square it, we get x square minus 2zx plus z square is equal to 16 minus zy plus y square. We get x square plus z square minus y square is equal to minus 2zx plus 8y minus 16 is equal to 0. That is zx is equal to 2 into 2y minus 5, because it is given that x square plus y square minus z square minus 4. So if you put minus 4 here, minus 16 will become minus 20, and then we have it. Now, from equation 3 and 4, so this is our equation 3, and this is our equation 4, okay? We get y into 2 into 2y minus 5 is equal to 6, so y is equal to minus half of 3. Now we put y is equal to minus half in equation 1 and 3, we get x minus z is equal to 9 by 2, and z is equal to minus 12. So we have two equations, two unknown, we solve, and we see that this is less than 0, which is not possible. So y is equal to 3 would be the only solution, and then you find x as 2 and minus 1, and z as 1 and minus 2. So with this, we come to the end of this video. I will make sure that I correct the question number 106. This is z square, and this sign is plus. So I'll make these two corrections here. And I hope that you have found this video useful and informative. So please subscribe to the channel and like the video so that more students like you can benefit, because if you like and subscribe, then it reaches to more students like you. That's how YouTube algorithm works. So once again, thanks a lot for watching. Enjoy.